Alright, today we're going to look at graphing linear inequalities without the use of a graphing calculator. First, I want to make sure that the inequality has y by itself, which our first example does. I want to identify what my slope is and what my y-intercept is. So looking at this, y is greater than negative x minus 5. My slope, which is the value in front of the x, is negative 1, or negative 1 over 1. And my y-intercept is negative 5. If I were to graph this line, I would start at negative 5, and then I would use my slope, which is down 1, right 1, to get to my next values. Here I can't go down anymore, so I would do the exact opposite. I would go up and to the left, 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 and so on. Okay? Inequalities are a little funky when we do graph them based on the symbols. So we have greater than or less than. It's going to be a dotted line, or some teachers like to say a dashed line. If I had greater than or equal to or less than or equal to, it's going to be a solid line. More on that in a little bit. So here, since we have the greater than sign, we're going to use a dotted line. So I have this. I'm going to use a dotted line here. Not the best, but it'll do. The one thing I also need is to figure out which way to shade my inequality. Since this isn't an equation, there's going to be a shaded region which will have points that make this inequality true. When we're not using a graphing calculator, I like to use a test point. That test point can be any point on this graph. The most common that I like to use is 0, 0, because when we multiply 0 by anything, it goes away. So if I'm going to use 0, 0, I'm going to plug 0 in for x, 0 in for y into my original inequality. And I'm going to see if this is true. On the left-hand side, I have 0 is greater than, negative 0 cancels out, negative 5. 0 is greater than negative 5 is true, which means 0, 0 is included in my solution set. So what I'm going to do is I'm going to shade everything towards 0, 0, including 0, 0 here. So my solution is going to be all points in the shaded region here, okay, except points on the line. Again, I'll talk about that in a little bit. If I were to pick a point that's on the line, for example, 0, negative 5, and if I were to plug it into my inequality, I would get negative 5 is greater than negative 5, which is not true. So a dotted line means that points on the line are not solutions. Another example down below, if you notice the only thing different is the symbol, I'm going to look for my slope. Since y is already by itself, my slope is negative 3, and my y-intercept is 4. So I'm going to start by putting a point at 4, and I'm going to use my slope, which is down 3, 1, 2, 3, over 1, down 3, over 1, down 3, over 1. And again, I look at my symbol to determine whether or not it's a dotted or solid line. This one, since it has the line underneath, it's going to be a solid line. So I start out here. I'm going to connect my dots. Again, not the greatest, but it'll do. And I again need a test point. I'm going to use 0, 0 again. I could use any point that's not on a line. So 0, 0 is right here. It doesn't go through. It's not on my line, so it's okay. I'm going to plug 0 in for y and 0 in for x. Left-hand side has 0 is greater than or equal to negative 3 times 0, cancels out. 4. 0 is greater than 4 is false. So I do not include 0, 0 in my solution set. I shade away from 0, 0. So here all the points not containing 0, 0, in this case on the right-hand side, will be in my solution set. I'm going to label that with an S. Alright, so hopefully that helped, and thanks a lot, guys.